Welcome back, everybody, to topic 6.2. The name of this topic is The Ocean in Motion. By the end of this lesson, you'll be able to recall how hot air balloons and lava lamps work. This is from Unit 5. Define upwelling and downwelling in ocean currents, and explain why buoyancy doesn't always determine if something will sink or float. There's sometimes other physics involved. Let's start with our brainstorm. So, do you remember these? We have Bernie's new hobby, and we have our lava lamp over there on the side. Why did the hot air balloon float? And why did the lava rise in the lamp? Pause this video and answer these questions using graphic notes in your notebook. So, those of you that had me for unit number 5, which is most of you, might recall that if we take a substance like, let's say, air, and we add some heat to it, then the particles in the air are going to start to move faster and they are going to expand. And if we add even more heat to that air, the particles move even faster than before and they expand even further. So density is decreasing in a substance when you add heat to it, which increases that substance's buoyancy. And if something is more buoyant, that something is going to want to float away. If you didn't get these responses in your notebook, then pause the video right now and add these thoughts to part 1 brainstorm. And this will finish off the brainstorm part of this video. And let's move on to part 2. Part 2 is called Moving Water. What you see on your screen right now is a map of something called the Global Conveyor Belt. The Global Conveyor Belt is a river of ocean water that connects the Pacific Ocean to the Indian Ocean to the Atlantic Ocean and the Southern Ocean. The Southern Ocean may not be as familiar to most of you. It is not an ocean that is generally recognized in a geography class, but it is in an earth science class because this is the waterway that surrounds Antarctica. The one ocean that has been left off here is the Arctic Ocean. The global conveyor belt does not carry water up into the Arctic Ocean. In the global conveyor belt, water travels along the surface. The orange are the warm surface currents before it sinks to the cold, deep currents below. It takes 1,000 years for water to travel all the way through the global conveyor belt, which is quite a long time, 1,000 years to travel through once. What I'd like you to do right now, please, is pause this video and use graphic notes to describe the global conveyor belt. Now, within the global conveyor belt, we have a couple of places where cold water from the deep ocean rises to the surface and warm water from the surface sinks down below. Those are called upwelling and downwelling. We're going to start by looking at upwelling. Upwelling is when cold, deep water rises to the surface. This seems to counteract the ideas of buoyancy and density because these cold water bodies at the bottom of the ocean are much more dense than the water at the top, yet they still rise to the top of the ocean. There are two places where this takes place: in the Indian Ocean and in the Pacific Ocean. And in both cases, the water is not rising because of buoyancy this time. This has nothing to do with buoyancy. In fact, it's a much simpler answer. The fact is that these water bodies on the bottom of the ocean are hitting land masses. They're hitting India and they're hitting Alaska. And if you remember, this whole global conveyor belt is 3-dimensional, meaning that even though it looks sort of flat on that map there, it's actually going up and down quite a bit from the surface of the ocean to the bottom of the ocean. So that area of upwelling right near India and right near Alaska, the deep water literally hits the land and gets pushed up to the surface of the earth. That is upwelling. Please pause this video and use graphic notes to describe upwelling in your notebook. Now let's move on to downwelling. Downwelling is the opposite. That is when warm surface currents sink to the deep ocean. And that still sounds like it has nothing to do with density and buoyancy, but this time it actually does. We are looking at the North Atlantic now. This downwelling is in fact caused by a change in buoyancy. That water will want to sink, but in order to do that, we have to cool that water off a lot. Cooling off the water will make it denser, that'll make it less buoyant, and it will sink to the ocean floor. These currents could technically power straight on through that strait right there in between Iceland and Scandinavia, but it doesn't do it. Instead, here's what happens. We have a water droplet, let's say, that starts over there in the Pacific. It was just upwelled to the surface, so it was on the ocean floor. The current hit Alaska and it got pushed up to the surface in the North Pacific. So that water right now is very cold. But as it travels along the warm surface currents, it gets warmer and warmer until it gets to the North Atlantic. In the North Atlantic, that water is quite warm, but the atmosphere in the North Atlantic is very cold. We are approaching the Arctic Circle at this point. So, what happens is that warm surface water starts to give away its heat to the atmosphere around it. That warms up the atmosphere and it actually makes the European countries warmer than they should be. A great example is London, England. London is at the same latitude as the Hudson Bay in Canada. The Hudson Bay is known for polar bears. London is not. The reason why? This water dumps off a lot of heat into the atmosphere to warm up the country. But that leaves the water itself now quite cold. And cold water is more dense, less buoyant, and it will want to sink. That is downwelling. Please pause this video and use graphic notes to describe downwelling. Now let's move on to part 3. Part 3 is called Sinking Water. I am going to, oh, it plays automatically. Hey, look at that. This is a YouTube video, a demonstration that's about as old as you guys are, where we take cold, dense water in blue and warm, buoyant water in red, and we dump them into a tank. And as expected, the red water floats and the blue water sinks. But eventually, as you see happening here, that blue water is going to rise to the surface and the red water is going to sink to the bottom. So something had to have happened here to make this occur. This kind of breaks the rules with buoyancy and density. So something else has to be happening here. Your job right now is to answer these two questions for part 3, sinking water. What is going on in this video? Remember that the red water is warmer and more buoyant. It wants to float. The blue water is colder and denser, so it wants to sink. But that's not necessarily what's happening here. And finally, how does this video, this little demonstration here, relate to the global conveyor belt that you learned about in part 2 of the video? Feel free to go back and play through that demonstration as many times as you want to while you're writing your observations. And pause this video when you are prepared. Use graphic notes to answer these two questions for part 3, sinking water. And that is it for topic 6.2.